Lesson 10, Day 4, Graphing Functional Relationships. Be sure that you read through the example problem here and the blue words as well, which is a solution for this problem. Number 14, Justin takes the bus home from school. He gets off the bus, walks a short distance to his friend's house, and stops to talk. Then he walks to his house. Sketch a graph for this story that compares distance from home to time and explain your graph. So the first thing that we're going to do is we have to understand what we're given in this problem. So we're given 4 major events. So the last thing we know that happens is he gets home, right? So he gets home. He's stopping to talk. That's what he does before he gets home. Before he stops to talk to his friend, he has to get to his friend's house. So that's 2. And finally, he's off the bus, right? But with getting off the bus, he didn't get off the bus at school. He got off the bus that took him from school to home. All right, so we start off at school, and I'm going to have school be up here, like very high on the y-axis, because if the lower, or if 0 is going to be his home, then we know that he's going to live a little bit far. We're going to say that he lives far away from his home. All right, so the first major event that happens is he's on this bus, and the bus is bringing him really close to home, right? So after he's on this bus, he walks a short distance, so it shouldn't be a very long way that he's going to his friend's house. So he's going to be getting closer to home because he got off the bus, right? So he can't be going that far. So he gets off the bus and then walks a little bit to get to his friend's house. Okay, so he's still going down. The distance is still decreasing. All right, so then he stops to talk to his friend. So he's not going to be getting closer to his house just because he stopped to talk to his friend, but him talking to his friend is going to take some time. So we start off from here with him getting off with his friend, getting off the bus and walking to his friend's house. Then he's talking to his friend. So that takes a little bit of time. Last thing, he walks to his house. So after he's done talking to his friend, he's going to go straight to his house. All right, so then when he's at his house, that means his distance from home should be 0, so we meet at the x-axis. So what you're going to do is we then see, well, we have these 4 major points, right? So we have he's getting off the bus at 1. He walks the short distance to his friend's house at 2. He stops and he talks to his friend at 3. And then 4, he's finally ready to go home. So we sketched it, and now we're going to compare the distance from home to time and explain our graph. So the first thing, Justin's distance from home gets closer to 0 over time. And as you can see, that happens, right? Because when we start off our graph, we start all the way up here when we start at 0, right? When he's at school. Then as time goes on, as time goes forward, the graph actually starts sloping down, meaning that the distance is decreasing as time is increasing. That's very important. All right, moving on. This, of course, as we said, is sloping down, or the overall line is going down, so the slope is negative. Okay, so the bus ride, the steepest part is going to be the bus ride. And the bus is steeper than the other parts because for the other parts he's walking. So he should be covering a lot more distance when he's on the bus than when he's walking. All right, so the bus ride is the steepest part. or let's say the bus rod has the steepest slope, because more distance is being covered. In a shorter period of time. And of course that's versus him walking. All right, as you know, that's just gonna be something that happens anyways. All right, moving on to number 15. The graph shows a carpenter's distance from the ground while working on a house. Describe what could be happening in each section of the graph. Alrighty. So in section A, since of course we're comparing the distance from the ground and time, in section A, this is really steep. Okay, so the steepest parts we're seeing are A, C, and E. So we could probably say that since this carpenter is working on a house, the house has a roof, so he's probably going to the roof. All right, so A, he's probably going to the roof, C is probably coming down from the roof, and E is probably going up to the roof again. So, and of course, to get from the ground to the roof, you would have to use a ladder. So we would say for A, C, and E, that this carpenter is climbing the ladder. Or at least for A, he's climbing the ladder because he goes from the ground up. E, he's also climbing the ladder. While C, he's going from the roof to the ground, so he is climbing the ladder down. He climbs down the ladder. All right. So then at section B and D, we can see the distance from the ground isn't changing, but he's staying up there for a long time. So we could probably say he's probably working somewhere on the roof of the house or on a plank of the house or something like that. All right, so we could say, So we could say he's on a plank working on the house, or he's on the roof. So he is working. Oh, it looks crazy. I don't know what he's doing. He could be doing anything. So D, or I'll just go to F and say he climbed back up that ladder, so he's working again somewhere on the roof. He could be building a chimney or something. I don't know what he's doing. Okay, he could be doing pretty much anything. The only thing that's left is D. And again, just because this is what I see doesn't mean it's exactly what you see. So your answers could be slightly different than mine, and that's fine. As long as they match up with your qualitative graph, you're good. All right, D. So D, after he came down from C, he climbed down the ladder, and then he stayed on the ground for a little bit, and then climbed back up the ladder to get back to work again. So he's back to work again. So what's he doing in the meantime when he's on the ground for so long? We could just say, like, maybe he went to go to his car to get a tool or something. I don't know. So maybe he went to his work truck. So he walked to his work truck. To grab a tool. I don't know. This is based on what you think could be happening in this time. Okay, I'm just speculating on what I would think would happen. All right, so again, this is just what I would think. I would think that B and F are the distance. They have the same distance both times. I would probably think that was the roof. You don't have to think of it that way. Maybe he's at a window and is just sitting outside doing something. I don't know what carpenters do. but this is the best I could do. Yours is probably going to be better. All right, so moving on to number 16. This graph shows Mr. Tosti's distance from home as he drives to work one morning. Which section of the graph and corresponding description match? All right, so let's look at these different sections. So we can see in section A that he's covering a lot of distance in a relatively short amount of time. Well, it's actually pretty gradual. All right, so in section A, Mr. Tosti leaves home, which, yes, that makes sense. First driving slowly, then picking up speed. Well, it doesn't really, if he was doing those two things, then it would be two different sections within section A. Since there's only one section, he seemed like he was driving pretty slowly. So in section A, it seems like, not slowly, I'm sorry, it seems like he was driving pretty gradually. So a gradual speed here. There's no evidence in this graph that shows that he did two different things, that he was driving slow and then picked up speed. No, because if he did that, it would look something like this, like he drove slow and then, and then picked up speed. But that's not what happened, okay? It's only the one thing, so he was driving steadily. Okay? Take that off. All right, and then the next thing that happens. So section B, Mr. Tosti, I can't say his name, I apologize. Mr. Tosti, he continues driving at a constant speed. All right, so his distance from home is still, it doesn't seem like it went anywhere. So I would think that he didn't. Since his distance from home was still the same thing, it's just a lot of time. Maybe he stopped at a red light or something. So no change in distance, which makes me believe that he stopped somewhere. And if he stopped somewhere, our section B in our multiple choice says that he continues driving at a constant speed. Time is still moving on, even though Mr. Tosti hasn't increased or decreased his distance from home. So I would not agree with this section B here, where it says that he's driving at a constant speed. I would think that he's stopped somewhere. So is he driving at a constant speed in section B? No, he is not. Section C, let me take this off again because it's really crazy looking. All right, section C. All of a sudden, he gets very close to home. So maybe he forgot something and he went straight home. Like he went all the way back down to the x-axis, which is 0, which means he's at home. Okay, this x-axis is 0, which means he's at home. So all of a sudden, he went from stopping at something. So maybe he stopped and looked for something in section B. But then in section C, all of a sudden, he quickly speeds home. He speeds back to 0, so all of a sudden he's back at home very quickly. So section C, he has sped back home because it's very fast. He covered a lot of distance in a short amount of time. It was so, the time that he finished section C, it was so small in comparison to sections B and A, if you look at them. Okay, so section C is extremely small, but the entire distance that he's gone has been covered. So he sped back home, probably because he forgot something. And that's exactly what C says here. So I agree that this should be our answer. Mr. Tosti forgot something and returned home to get it. Section D, finally, we're there. Let me take this off. Section D. Okay, so it looks like he is ready to go. I guess he's going to work. Yep. So it looks like he's finally there. He goes straight to work, about at the same speed almost that he had in section A. So he is off to work. And he didn't stop anymore. So he went straight to work after he went back home. There is no stop along the way, but he did drive to work. He didn't even speed to work. He just drove to work. Okay, so I agree with section D where it says he drove to work. Yes, but he did not make a stop along the way. That is a straight line. Again, if he made a stop along the way, instead of it looking like this, it would look like, okay, he did this, made a stop, and then continued on his way. That's not what we're doing. Okay, he didn't do this. He went in a straight line. Okay, this is what Mr. Tosti did. Okay, so he went straight to work. All right, so D is incorrect. So Amir chose D as the correct answer. How did he get that answer? So Amir didn't understand that making a stop means the distance doesn't change. Section D shows a constant change in distance. Okay, section D is a straight line, which means it has a constant rate of change. But with that example that I had here, if I can take that off, which I cannot, sorry. Well, with that other example that I drew out with him going a certain distance, then stopping, and then going back, that's not linear. Okay, so this is non-linear, which means it's no constant rate of change. All right. Okay, so that's what we'll say. Section D doesn't constant D does. Section D shows a constant change in distance. All right, and that is it for day 4.